Good morning. Today we're going to review assignment number 4. The design for assignment number 4 is due Thursday, March 26th, the Thursday after we return from spring break, online, of course. And the implementation of assignment number 4 then is due the Thursday after that. So, assignment number 4 is about a concordance, building a concordance, and using a hash table to do it. So what is a concordance? You see in the description here what a concordance is. Nowadays, with reading files, we can automatically generate a concordance, and that's what we're going to do. So there are 3 classes that you need to create. The data element, which we call the concordance data element. The concordance data element consists of a word, which is a string, the word that you read, and a linked list of line numbers that it appears on. Now you can use the library class linked list as to put your linked list of line numbers. It will be a linked list of integer. The second class that you need to create is the concordance data structure, and it needs to be based on the interface that's provided. The concordance data structure will be built on a hash table with buckets. This is like the second version of the hash lab. So you don't have to follow the detailed algorithm. You simply hash it once, and if there is a collision, you just realize that CDE gets added onto the linked list. Once again, you can use the linked list from the library class. So for example, here, if you come up with CDE number 4 that also hashes to 0, 1, 2, the word hashes there. So the hash code of word in this example is 2. So there's already something in 2, so you add to the end of the linked list. So since it's a hash table of buckets, a hash table in general, you need to decide to compute how long the hash table is going to be. So the length is going to be a 4k plus 3 prime. I refer you back to the hash table, the hashing slides that we had last week to discuss how to compute the 4k plus 3 prime. And in fact, there's two exact examples of computing 4k plus 3 primes. So that, in this example, is only used to compute the length of the hash table. So there's a couple things about the data structure that you need to know. First of all, it will add a CDE, a concordance data element, which already consists, it's an object then that consists of a word and a linked list of line numbers. So the add method of data structure will take a word and a line number to be added. If the word already exists in the hash table, then the line number will be added to the linked list for the word in using the concordance data element methods. If the specific line number for the word already exists, don't add it again. In other words, here's the example. If Sarah was on line 5 twice, the first line 5 would be added and the second one would not. But if the word doesn't exist, you have to create a concordance data element and then add the CDE to the hash table. So there's 2 constructors in concordance data element. The first takes an integer, that's the estimated number of words in the text, and the second is just used for testing purposes for the JUnit test. and it has the word, it provides the word testing, but you don't have to manipulate the word at all. So it says look at the provided Java doc. Let's go find it and look at it. So the provided Java doc, there's a concordance data element, concordance data structure. So let's look at the concordance data structure. Here are the two constructors. The first one just takes an integer, which represents the estimated number of words. Now, in the actual test methods, we estimate that to be 500, but you don't have to provide the 500. You just provide the int num in the constructor and set that somehow in your code. The second constructor is used purely by the JUnit testing, and the string testing will be set to test, but the important thing is the size, which will frankly be 20, and then we'll test using JUnit test to see if 20 got set to the size of the JUnit test. So this basically tests the variable, which is the size of the table. A couple more things, as long as we're in the Java doc of the concordance data structure. Here's a method to add the concordance data element. Use the hash code of the concordance data element, which is the word hash code of word.hashcode. Now, since word is a string, hash code is already defined, and so you can use just word.hashcode returns the hash code of that word and also of the CDE. So hash code of the CDE is just down in the guts of the program, just the hash code of the word. Now the second method, get page numbers, is the wording, the naming of the method is a little bit off because it should be get line numbers. But of course, in a normal concordance, you list the page numbers that a word appears on, not the line numbers. Now, since we're reading from a text file and we're going to read line after line after line, and we don't have any real delimiter of pages, we're going to replace that page with line, but you still have to create the method called get page numbers, but they actually take as an argument a line number, and it says index is the name of it, is the parameter. That's basically the line number that word appeared on next. So then there's get table size, get words, which returns just the words in the CDEs for a given index. Get page numbers, by the way, looks up the hash code in the index and returns the page numbers of the specific, for each word, an array list of the specific words, of the specific line numbers of each word. So there's details down below, and it'll return the linked list of the CDEs. And like I said, get words will return just the words, an array list of just the words that show up at that index of the array list. And then show all will display all the words, so they have to be sorted into alphabetical order by the alphabetizing of the word in each CDE. And so the example is shown down here below: a word and a colon followed by line numbers that it appears on, separated by commas. So we go down into the method detail. You see a little more detail for the get page numbers and get words and show all and add. Okay, let's go back to the document now. So as I said, you need to compute the 4K plus 3 prime, the length of the concordance data structure. So let's go on to the data manager. So the concordance data manager implements the interface. So that tells you what methods to create. And it allows you to create from a concordance file to create a file or create a list, an array list of strings. So you read the input from either a file or a string, and line by line, and you add it to the data structure through the add method. So you should change all the words to lowercase so that they're all now, capital N now and lowercase n now are considered the same word. So there's a list of classes rather in the Concordance Data Manager interface that Concordance Data Manager needs to implement according to the comments in the interface. In terms of exception classes, you don't need to create any new exception classes, user-defined exception classes. IO exception is basically the only one that you're going to need. We provide the GUI. There are two ways that the GUI can be used, either to create a concordance file when they've or to read from an input file. And secondly, to read from a text area in the GUI. So you need to create a file chooser, read from a file chooser. I think the GUI does that to select the input and output files so that you're able to select the files that you read from and write to. If there's an error, the GUI will throw an exception. In terms of the student testing, what I'd recommend you do, first of all, there is no file named student test. So what I'd recommend you do is copy Concordance Data Manager test and rename it Concordance Data Manager student test and modify the tests to be applicable. See the format that's in Concordance Data Manager test and modify those to fit the requirements. So when you're creating a concordance, not counting the test method constructor that just does testing in size 20, that checks for the size, there are two ways other than that to create a concordance. The first requires a text document, and the concordance data is written to an output file. Second reads input from a string in the text area, returns an array list of strings that represent the concordance. Now, in terms of specific small words, there are a lot of small words in the English language that you don't need to include, things like of and do and so forth. You also don't include the words the and in your concordance. So you don't include words that are of length strictly less than 3. Now, in terms of punctuation, you do need to be careful that that you strip out the trailing period of a sentence, because if you don't, those words, the word string, dot, like the line up above, will appear as a separate word than string. So you need to strip out the trailing punctuation, but for apostrophes that are in the middle of words like let's and weed, you need to include those because that's considered a separate word. Okay, well, good luck, and remember that the design is due the Thursday after spring break, 2 weeks from the day this is being recorded, and the implementation of Assignment 4 is due in 3 weeks, a week after the design is due next week. So that's all.